Welcome to June's Leetcode challenge. Today's problem is range sum query mutable. Given an integer array nums, handle multiple queries of the following type. Update the value of an element in nums, and calculate the sum of elements in nums between indices left and right inclusive. Now, to give you a couple information here, but really it's self-explanatory. We just want to be able to update a value inside of our array, and we want to calculate the sum of a sub-array here, given the left and right index points. So at first glance, this seems really easy. We can just use an array, say self.nums, and we'll just make that nums. For updating, we'll take our self.nums, get our index, and update it to the value. And for the sum, we just return the sum of a subarray here, right? We'll take self.nums, we'll say from left all the way to right plus 1. And that would be it. But unfortunately, this is going to reach a time limit exception because we make m number of calls here, quite a few calls, and worst case scenario, this operation here takes O of n. So this would be worst case m times n. Now that's not good enough. Now one way we could think that we might be able to avoid this is, what if we had a prefix sum array as well? If we had like an array 1, 3, 5, we had another array that calculated the rolling sum, starting with nothing would be 0, and we'll have 1, 4, 9. This would allow us to calculate the sum in O of 1 time. What we would do is take the sum all the way up to the right and subtract it with the sum all the way up to the left. So if we want to get sum of this, we'd get 9 minus 1 here, and that would be 8, right? And we can see that's 8. But unfortunately, even though that increases this to an O of 1 time, updating it would require O of n time as well. If we like updated this to 5, now we have to recalculate all our prefix sums, which takes O of n time. This would be like 6, and this would be 11, and so on and so forth. So that doesn't work either. I'm not going to go into that. Is there any other way that we could do this? To improve it any further, we would have to have some sort of other data structure. And there's two methods. You could either use a segment tree or a binary index tree. Now, binary index trees are a little bit easier, but they're still pretty hard. So I'm going to put a link in the description that explains it pretty well, a video that I found. But the basic idea is, say that we had some array like 137. Instead of having the prefix array, like the entire rolling sum, we're going to have like subarrays here that calculate the sum up to this point, but using the binary representations of the number for indicating the index point. That's going to make it logarithmic when we calculate the sum. So what that means is we calculate from binary index trees are going to be one index, so we have to have a dummy node here. And so this would be like 1. This would be 1 to 2 would be 4. But at 5 we start over, because 5 this represents what? Like if we said this was 3 binary representations, like something like that, right? And we're going to calculate the sum from this point to this point, so that would just be 5. But for index point 4, this is going to be like this. We're going to calculate the sum all the way from 0 all the way here. So that's going to be what? 12, 15, 16. Now what this allows us to do is, if we want to calculate the sum of 0 to 4, we just calculate, okay, whatever the sum is here, we get rid of our rightmost one, and then that would be the value, right? But if we want to calculate for the third index point like this, where we take 5, okay, pop that off, and then we calculate up to here, which is going to be 4, and that's going to be 9, right? And that's going to make it logarithmic for both updating and finding the sum. So let's build a binary index tree class first. This would be, let's initialize, first it's just going to have an array, and we're going to pass in the length, and we need to add 1 to this. So we'll do, say, call it sums, and this will just be equal to first all zeros times n plus 1. So next we need to have a update function, which is going to pass in the index and value. Now one thing to note is, for this update function, the value is actually going to be the delta, which means it's going to be the difference in amount from the original value of our number to whatever this value is. And the reason for that is, if we reset it completely, like a new value, it would require us to go through the entire binary index tree again. So instead we're going to pass in the delta. Now what we'll do is say while I is less than the length of self.sums, we are going to add to self.sums at this index point, whatever the value is. Now we're going to increase. We're going to add one rightmost index point here, and that's going to push all the ones up to whatever values we need to also add this value to. So this will be plus equals to I and negative I. And that's kind of a trick here. Now, finally calculating the sum, we'll call it query, and this will just require us to pass in the index value. And we'll say, okay, while I is greater than 0, we are going to first initialize our result as 0 here. And we'll add to this result self.sums I, and we'll decrease by the rightmost one. Finally, return the result, and that's going to give us all our functions here. Okay, so now it's just a matter of using our binary index tree, right? So let's first initialize it, call it b, and so this will just be a bit of the length of nums. We also need to store nums here because we need to calculate the delta when we update. So let's first initialize our binary index tree to be for iv and enumerate nums. We are going to take our binary tree and update it with I, but we need to add 1 here. Remember, the binary index tree is 1 indexed, and take our value. So now for updating, what do? We take our self.b, we update with index, we add 1, and we pass in the value. Oh, that's not true. We need to calculate the delta, right? So delta is going to be value minus self.nums index, and we don't pass in the value, we pass in the delta. Now, one thing to note is we need to update nums as well, because we might keep updating the same number, right? So we need to calculate the new delta, which would be this. Finally, for returning the sum range, it's similar to how we did it before. It would be similar to how you do it with just a regular prefix sum array. We would take all the way to the right, self.b.query. So we take right, and we have to add 1 here. And here we're going to say minus self.b.query left, but we don't need to add 1 here because it's inclusive. Okay, so let's see if this works. Okay, that looks like it's working, so submit it. And there you go, accepted. So time complexity is going to be worst case m times log n, which is much better than m times n. Now this, I think, is a pretty hard problem. It's a good exercise to learn how a binary index tree works. But other than that, it's kind of, man, it feels like overkill doing it this way. But hey, that's just part of Leetcode. All right, thanks for watching my channel. Remember, do not trust me, I know nothing.